Write the number 3 as a square. Okay, so 3 equals 3 times 3. What do we have to do to keep those values equal? Exactly, so you're going to have to put a square root sign in there. Okay. What about 5 as a cube? So 5 equals, the cube would be 5 times 5 times 5. What do we have to do to keep them equal? Slar, what do you think? Not square root, but cube root. Okay, so the index must be a 3, then they're the same value. Okay, just like over here, please simplify these. Since the index is a 2, we can take out a single value. Here our index is a 3, we can take out a single value. Index is a 4, and we have 4, so we can take out a single value. And that's all we're kind of doing today. Okay. All what we have to do now is we have to find that. And that's where we're going to look at prime factorization, which we did at the beginning, very first day. Okay. So, write the number 8 with the index of 5. Oh, how about you guys do that for me, please? Go. How many, Rylan?
Oh, 5.
Bingo. See? Genius. 1. Oh, hey, what did he say? Wrong number. 1, 2. No, you did it right. I'm doing it wrong. 3, 4, 5. There we go. Okay. You guys get this stuff? All right. We can write this 3 different ways. So we can write that as 3 times 2 times 5, or we can write it as 5 times 3 times 2. Whole bunch of different ways. Okay. Now we could also even mess this like multiplicate. What did I just show you here with these 3 examples? Yeah, change order of multiplication. Does it change anything? Not at all, right? What you can also do is go square root 2 times square root 3 times 5, right? Or square root 2 times 3 times square root 5. Right? Exactly the same. It's kind of a cool thing with the root sign. Right? So sometimes we will square root some stuff, and other times we won't. So let's just go over our definitions. An entire radical, that is when you have no coefficient. Okay. And what are our names? What do we call the n? What do we call the x? Radicand. Now we use the word index a lot, but we don't really use the radicand all that much. Don't know why. It just doesn't come up too often. Now if you have a mixed radical, now we have a coefficient. Okay, so now we have a coefficient. And what you want to do when you're looking at this stuff, you always want to make sure that x is in lowest terms, like a fraction. Okay, so you can't take anything else out. So what I'm going to give you is some stuff that's not in lowest terms, just to check you out. We'll go over those in a little bit. Any questions about the difference between an entire and a mixed radical? All we're going to do now is go back and forth, back and forth, back and forth, back. All right, so let's talk about how to simplify. This is different than evaluating. Usually when you're evaluating, you're going to go and grab your calculator. Okay. What we're going to do though is non-calc, and this is on the non-calculator section. 100% guaranteed stamped. It will be on the non-calc section, and it's easy enough for you guys to do. Okay, it won't be super crazy hard big numbers. That will be on the calculator section. Letters, where your calculator is a useless piece of junk, that's on the calculator section. Okay, we try and get you to do as many questions without a calculator as possible. So What we want is an exact value, not the decimal approximation. And that's why our calculators are a little useless. So the index will tell us the groupings we need. Here the index is 3. We need groups of 3. Index is 7. Groups of 7. What we want to do, first of all, is rewrite using prime factorization. Again, I'll show you several pieces of work here. So 240 divided by 2, 120 divided by 2, divided by 2. Keep going, please. Use prime factors. Okay. Now what I want you to do is rewrite this. 240 equals, and you want to put them all together, but keep all the 2's together and the 3's together. Okay? So we have 4 2's, we have 2 3's, nope, check 1 3, thank you, and 1 5. Okay. So step 1 is done. Okay. Now what's step 2? Look for groups and remove the number. So here the index is a 2, we're looking for groups of 2. There's a group of 2, we can remove a 2. There's a group of 2, we can remove a 2. Notice how when you remove them, it's still multiplication. Can we remove any 3's? No. There's only 1. What about 5? Can we remove 5? No. So those guys come out, and what we're left with is 3 times 5. Now we're going to multiply together. So what's on the outside? 4. What's on the inside? 15. Okay. Now, I can do this a different way as well. Check this out. Don't write this down. 1, 2, 3, 4. I could, in the textbook might do this, go 2 times 2 times 2 times 2 times 3 times 5. Right? Different way of writing it. It's all good. This would be 2 times 2 times 15, 4 root 15. Okay? We don't want to put a multiplication sign in between here. Because they're side by side, it's multiplication. But don't do this, because that's so wrong. Right? You got to be careful where you write the 4. How you guys doing? Okay with this? Okay. Now there are other ways. You go to the internet and you'll see a few different ways. There's probably about 4 different ways of kind of doing this stuff. What we want for your work, and I know sometimes we get lazy, and that's okay. You can even just use this guy. Oh, take out a 2. Oh, take out a 2. And then you can rewrite it and go to your answer. Okay. But this is kind of this is a good way to understand the concept. Thumbs up down the middle. Rate yourself. Go. All right. Perfect. Here we go. Next one. We're going to go with root 48. So let's do the division first. Oops. 48 divided by 2 divided by 2. 2. Okay. Now I want you to rewrite so that you're building this concept in your brain because it's an important one. Okay, so please rewrite. It allows you to understand why we can do this. Are we looking for pairs, triples, groups of 4, what? Pairs, why? Index is 2. Okay, your index tells you what to look for. All right, here we go. Oh, I should be more scripted here. It's the second one. Easy button. Hands up if you got 4 root 3. Oh, you guys are all stars. Perfect. Next one, 3 cube root 32. Oh, looks like it's done. Let's go on. It's done, right?
No, it's not in those terms.
Bingo. This is one where it's not in lowest terms. If I give that to you as a question, if you leave it, it's 0. Okay, you've got to put its lowest terms. So let's not worry about the 3 in front, but that 32, let's go ahead and factor that guy. Go for it. Okay, who's got a final answer? Go for it, Sam.
8 squares 2.
8. How'd you get the 8?
3 times 2 times 2.
3 times 2 is, yeah, you added, I think, eh? Yeah. Okay, so 3 times 2 is 6, times 2 is 12. 12 root 2. All right. Hands up, you got that? Okay, any questions? Questions? Anything? All right, I want you to do 4, 5, and 6. Go, see what you can do. Work with the person beside you. I'm going to come around. Chris is going to come around too. Please ask. Number 4 is a little tricky. What do you guys think about number 4? Any pairs?
No.
Any triples? No. So what can you say about number 4? It's already in. So what are you going to write? Oh, you can take something out? You're going to rewrite it exactly as it is because that tells me it's in lowest terms. So you're just going to write down equals root 42. That shows me you worked on the question and you know that that is the actual final answer. So just like a fraction in lowest terms, you got to tell me this is lowest terms equals root 42. Okay? Very rare, you won't see it too much, but it might come up. So you just got to rewrite it, show me you know that's the answer. Not that you don't know how to do it, you know that is the answer. Okay? Number 5 would be a little more straightforward. Same with number 6, I believe. Okay? Good luck. Go. 5 and 6. Do you have a phone? Yep, use that. No texting or step out of it.
We're all texting school.
Chris knows. Okay, awesome. What's this one? So what can you say about that? Okay, so you see how I have a V showing that there's two clouds? Or look at the very last one. So I think it has to just stay as it is. Well, no.
Oh, or the three by two.
Remember right here, is 0, 0, 1. So that's what we're doing. When it's switching those seals at 3 times a single value 2 times a single value 2 because they're combined. But the last one doesn't come out, so it stays inside. Well,
Oh, yeah.
okay, if you guys want to work ahead, do number 9 and 10 on the back. Okay, so on the back side, if you're done, we're only doing numbers 9 and 10. I'll go over this front side in 1.5 minutes. Okay, so number 9 and 10 on the back side if you're done. Okay, close. You can take out 16. What is your only thing remaining? So those two are out. Those two are out. Those two are out. Those two are out. And there's nothing remaining. Look at them all paired up. Right? Can you circle the one that's remaining? So you actually have one remaining. So that's just 16. This one's actually. Once in a while you see that. Me first. Oh. 16 out. Right? Put it back in. And I go to 2 up to 6. So I put 4. That's a good sign. And we pair with that. You see the head. So if I look at squares on here. Oh, so good. Yes, 256. But the 200 they can't get the square root of 56. So you're saying 16 equals 256. No, no, no. 16 equals 256. See how you got the square roots on both sides? Now you got both sides. So you have those. Just do yes. Perfect. Okay, first one here. Oh, sorry. Keep working, keep working.
That's only if extra letters that don't have, or extra numbers that don't have a letter.
So, which one?
For number 6,
Yeah.
how do you do it with when the index is?
What are you looking for? Groups of 3 of the same number. There you go. No. They all pair up. This needs to be long. cover them, all of them. Okay, so that's the first thing. That is incorrectly written. So we need to make it long all the way. Here, 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 here. You got one extra. Yeah. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's why. Okay. And so there's nothing left over. Just 16. No. This is out. Oh, sorry. No. I'll go over it in a second. You're looking for groups of 3. This is not right. It must be inside your check mark. In there. Okay? And then long with triples. That's left over. Okay, number 6. 24, cube root of 24 equals 1, 2, 3 times 3. Shh, focus eyes up here, please. So 2 times 2. Michael, I'm speaking. Please, thank you. All right, take out a 2. What's left? Cube root 3. This is wrong, folks, to write this. This is 3 times cube root 3. This is 3 times square root 3. That's wrong. You must put your 3 inside your check mark. Okay? Be very careful how you're writing this stuff. Good. Okay, turn over, next page. 405, 40, 50, divide by 5, it's 81. Divide by 3, 27. Divide by 3, 9. Divide by 3, 3. So this is the 4th root of 1, 2, 3, 4, and a 5. And so you can take out a single 3. There you go. Okay. 3, 4th root of 5. Any questions? Okay. Yeah, what's up, Tanisha? Oh, you had a question. Oh, ask it. I'm going to wait for you now. Oh, okay. I do mess up often, so watch me. Okay. All right. Any questions? Okay. Next one with the letters. So it's helpful here to expand it. Do you know what the exponents actually mean? Okay. And then there should be 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now you can look for what? What are we looking for? Groups of 3. So we can take out a single A. We can take out a single B. And there'll be 1 remaining. We can take out 1, 2 C's. Okay. And then what's remaining? A single B and a single C. Okay. Do we need to have multiplication signs for letters? No. We show multiplication by writing 2 letters side by side. Now, since we have 2 C's, what's the shortest, easiest way to write that? C squared. And we have some stuff left behind that can't be removed. There you go. How's that? Okay. You'll probably get 1 or 2 of those. All right. Any questions? If you can do that, you can do anything. Okay. Well, if you know what you're doing, it is. Okay, so now we're going to go the other direction. Right? Now I'm going the other direction. So the index tells you how to bring the number inside. If it's an index of 3, you must have 3 of the numbers. So here our index is a 2. How many numbers should we have for the... How many 3s should we have? Good. So 3 times 3 times 2. And then we multiply them together. 18. Good. Do the next 2. Go. Finish off number 2 and number 3, please. Use your calculator to get the final value. $768, is that right? Good. Okay. There we go. Any questions? Yes, sorry, Angela.
For number 2,
Mm-hmm.
do you have to simplify it?
But if we simplified it, this is what we get. So what we're trying to do is go and make it more complicated. So we're going from a simple Euler one to the entire. Okay.
Okay.
Okay. All right. So next, what we're going to do now is just kind of estimate a range from least, which is the smallest, to the largest. Okay. So from small to large. So what we want to do is, this is non-calculator, we want to change to entire radicals first. What's bigger, root 49 or root 48? Yeah, okay, you guys think, oh, me, it's backwards. No, this is definitely bigger. Okay, it's a bigger number. So then where would I put root 40? Would I put it on top or on the bottom? Bottom. It's totally smaller. It's a lot smaller, right? So just because we don't know the exact value of it doesn't mean we don't know if it's bigger or smaller. Okay? So that would be the order. This would be the smallest, and that would be the largest. So what we want to do, it's hard to compare a root 2 and a root 6 and a root 3 because we got numbers outside. So it's like, what's going on? Guess what we need to do? Change them to this first, because then it's comparing some easy numbers. So go ahead, A, B, C, change them. Go. Did I do that right? Root 98, root 96, root 108. I hear calculators being touched. I'm not sure why. Maybe we didn't read without the use of a calculator. Okay. Good. Now these ones are tough because there's a different coefficient and different radicand. But look at D and E. Okay. D and E, they have the same coefficient and the same radicand. Okay. But the index is different. Which one's bigger, D or E? Mm. Well, this one is going to be simplifying into 3 numbers that multiply to 10. This one would be 4 numbers that multiply to 10. Okay? So this number here would be larger. So right away, without even knowing the value, D is bigger than E. Okay. Okay. All right. You should do that. No. Okay. So what we have to know now, like we can compare here A, B, C. Which one's the biggest? Yeah. C. Then what? Then A, and then the smallest is B. Okay, so this is the smallest going to the largest. So the question is, we know that E is smaller, D is bigger, and that's because of the indexes tell us that, right? Everything else is the same. So where does E and D belong? Do you think they're going to be a big, like, whereabouts are these guys? What perfect square are these close to? Yeah, 100. That equals 10. Okay. What about this? Okay, a perfect cube that multiplies to 10. Let's do a little estimation here. So cube root of 10. What's a perfect cube below it? 8. Cube root 8 equals 2. And what's above it then? 3. 27. So this guy is going to be about what? Like maybe 2.1. Okay. 2.1. Something like that. So what we have is we have right here 2 times 2.1, which is going to be like 4.2. So should D and E go here after these numbers, which are close to 10, or before the numbers are close to 10? Should go before. So the order should be E, D, B, A, C. Okay. Right now on your calculator, please do 2/4 root of 10. Tell me what that is. And then go to cube root of 10. Tell me what that is. What's the first one? Times 2? Did you do the times 2 part? Double check. Do it on calculator again, please. This is a calculator check. Everyone do this. 2.297. And what's the other one? 2 times 3 cube root 10. 2.23. I have these ordered backwards, don't I? Stand by one. E is bigger than D. Okay. Okay. Okay, so estimation, a little bit different than with the calculator. Let's just leave it at that. Okay, once you start getting to the 3s and the 4s, it's not very accurate with your estimation. All right. Regardless, BAC, this is really what we're looking at, is making sure that you can tell which one's smaller, which one's larger. All right, with the square root sign when they're identical. Any questions? Yeah.
I got different answers for the 2 and this 4.
What'd you get?
I got 3.56 and the 4.31.
Okay.
After doing
Okay, just a sec. Let me check on my good calculator. 4. So 4th root of 10. Yep. Times 2. 3.556. And 3 root 10. Oh, I know what I did wrong. Was that times 2? 4.3. That's because I have an old calculator. 10 root 3 equals times 2. Ah, there we go. Okay, so calculator problems for me, estimation was good. Alright, so what I did is I entered this thing wrong into my calculator. Make sure you bring the calculator you're using for the tests. Alright, good. Big difference between the calculators. Alright, any questions? Sorry for screwing that up.